to the world, to the society. One of the companies supplying energy and material. To do all that, right from extraction of oil, which is then below the earth's surface, to energy that you all experience and use daily, something is happening. It is actually a marvel in engineering. You just step out your home, you see in the road there is a bitumen is road that is laid. You get into a vehicle, it is powered using energy that is coming from a fossil fuel. Each and every material that you are either in your vehicle, in your house, most of the materials have come from fossil fuel. It will have a petrochemical in it. It will have a chemical base which is coming from one of the products what we make. So it's innumerable what we have been doing. So let us quickly go through what else the modern refinery, how it looks like, and what do we do. Modern refining engineering is one of the most sophisticated achievements of industrial science and system integration we have done. Refineries are anchor of the downstream sector. We have upstream where we extract oil, midstream where we distribute, downstream where we refine and take the products to the final consumer. The modern refinery look like a big, huge complex of columns, heaters, various equipment, compressors, pumps, and etc. As I told, curriculum has not much changed in the college. Nevertheless, progress industry has changed, and it is changing leaps round, and it is pole vaulting action. Then how do young engineers will know what is required for them to be equipped with before they can step into the industry world? So interactions like this, like with the industry what we are having, will definitely help us in getting engaged to know what from an industry point of view, what do we call as an achievement, what do we call as an improvement, and what young students should know before you step into the corporate world. So in the next 10-15 minutes, you will just see what all are required to make an engineering marvel. Now let us see what it takes to take the crude from the ground and to make it as a valuable product. The molecular complexity to engineered value. Crude oil is a mix of thousands and thousands of different types of compounds. It will have all the chemical compounds that you can locate in the world today are all present in this crude oil. And each type of crude has a unique molecular fingerprint. Analysis of a crude, understanding what it can do is itself is a complex chemistry and analytical knowledge is required for that. So first we start with a molecular level characterization, designing my downstream to handle that. How do I operate continuous mega scale plants with atomic scale reaction control? It has to be very, very precise. It has to operate round the clock, high reliability and very, very safe. Each and every compound we are handling is highly flammable. In spite of that, we handle it with ease because of the knowledge what is chemistry and the knowledge what engineering has given us, and also the engineering controls that we are able to use. So these are all operated very safely, very reliably, and without affecting the environment to a large extent. Now, let us go back a bit and see the journey of crude oil refining. In the pre-industrial era, people saw the oil and they saw that they can use it for topping of roads, to waterproofing of their houses, their huts. So mainly bitumen was the first product which came out of crude, and they all were used for the betterment of their life at that point of time. Gradually, people understood there is another lighter product in this crude, which is nothing but what we call as kerosene today, which can be lighted to power on the homes. So that was the second major product which came out of crude. And the birth of modern refining took place in 1950 to 1900, when we understood that once I separate kerosene, we have now a better product to handle. We also then came the era of automobiles. Automobiles, they understood as the engines were invented, So the automobiles helped us in moving from one place to another, which brought in very ease of mobility. Along with the increase in these devices which could use the energy, also grew the chemical processes also. Breaking of molecules were learned. Thermal cracking was the next biggest chemical process which came. By catalyst can accelerate the chemical process. So catalytic processes took over during the World War when the requirement of energy was multifold. So then the catalytic processes came through catalyst, catalytic energy technologies started progressing in the uh, World War era. Subsequent to that, we entered the hydrogen era, meaning we wanted more clean and more different types of products. The hydrogen entered in 1950 to 1970s. Hydrotreating technologies came. We started removing all the impurities in the crude and then started using, which extended the life of our end users. Then during the war of Gulf War in 1970s, there was a shortage of crude oil. It was observed that a very few countries were holding the entire wealth they were having, which is the black gold crude. People understood. Now, with whatever little I have, we'll have to extract more. Then came the bottom of barrel upgradation technology, deep conversion in 1970s to 1990, where we started converting heavy molecules into lighter molecules. Next came more and more environmental awareness and more quality consciousness. Then we introduced Euro standard, Bharat stage standards, which is nothing but defining our diesel, petrol, LPG standards, which says how much of impurities you can allow, how much I'll have to maintain the other quality parameters. So we started improving all, and the technology started growing in these areas. Today, I can proudly say we are now making 100% clean fuels from our refinery with very minimum environmental impact and the best quality which we can give it to the world. These are all made possible by digitalization, by integration of various processes into large complexes. These are all made possible. Apart from the energy, what I have been talking about, large materials, petrochemicals, carbon nanotubes, materials that go into making tires, so on and so forth. Everything comes from this very simple crude molecule what we get from Earth. In future, what we look, already we have started many of these areas. We have started the energy transition. We want to have a energy growth in a sustainable and a surveyable. We should have equitable distribution across the society in a sustainable way. So now we are going for more and more integration for materials production. We are bringing in bioenergy into this to reduce the CO2 footprint. We are making green hydrogen, carbon capture. Future may see electrified furnaces. So the refining will continue for several decades. It will continue power. It will continue energy for all the sections of society for several decades to come in a more responsible way and a more effective way. So this is the next era which is going to come. Now I just completed the journey of crude oil technologies, refining technologies. The same one, let us see what are the advances that are taking place, which you all should be interested in. You will also be contributing to several such advances in the future. Believe me, crude oil refining or an energy industry is never a sunset industry. It is an evergreen industry. Always it evolves. It caters to what the society requires, and engineering contributes to that. To cater to that transition, engineering is required to meet all that transition needs. I talked about distillation, which is the primary source, which came as early as 1900, in the year 1900. But now, the same distillation process, some of you who are chemical engineers would be reading mass transfer, heat transfer, transport phenomena from the books where you will be reading distillation. But today we are much highly advanced by using highly efficient structured packings, divided wall columns, heat integrated distillation columns. Using pinch technology, we have integrated our heat recovery system into the crude distillation. We have intensified the process into a occupying very small footprint using rotating packed bed. There are many such advances that have taken place. You need not be worried about the terms, but do understand one thing: the technology developments take place continuously. Engineers like us, the technocrats like us, the professionals like us have to contribute to continuous development of this. Many of the technologies so far we have been taking from different licenses across the globe, but now time has come where India will have to start doing it in the indigenous way. So from HPCL side, we have also developed quite a few technologies, catalysts, materials, chemicals, which we are using for our own uh, refineries, and in future they will all be showcased for the entire world. The other main areas are advanced separation, energy intensity reduction, capital and plot plan optimization, reducing the water footprint. How do I operate it with more flexibility, reliable, and increase of run length? These are the challenges which you will all be seeing when you enter an industry, be it our own industry or it can be any other allied industries also. uh, Next, we saw the conversion technologies. The conversion technologies have been greatly enhanced by the advancements in catalysts. Catalysts, which you are chemistry students, you will know that they are all used for enhancing the rate of reaction. So we have now high severity FCCs, residue-based hydrocracking technologies, directly converting crude to chemicals. These are all the new technologies that are coming up. Many are already used in a large scale, and many more are in the anvil, which will be coming up very shortly. They will all be commercialized. The treating technologies, that is another main improvement that have taken place. The use of hydrogen to remove all the impurities. You reject the sulfur and convert that sulfur into a fertilizer. So these are the invisible enablers which are helping our industry. How do I bring the power at the cheap? How do I bring steam at a very cheap cost? So they are the utilities which again will help us in improving our operation. How do I make the product blending? Bring in automatic control with less intervention. We keep meeting our quality control. All of these have been come through engineering marvels. I will introduce to you one more term, which is called total distillate. Suppose I take 1 unit of crude, how much of unit I can convert into useful product is called total distillate. 100 tons of crude, if it gives 54% of petrol, diesel, LPG, then the total distillate number is called 54%. What you are seeing as the first number, 54%, this is how the industry started. Gradually it improved to 70, 74, 80, and now we are 90 plus. Each one of this number increase is made possible by technological advancements. And many of them, when you visit a refinery, you will see the marvel with which they have all been designed and constructed. Each one of them have been done by engineers like you and me. Now, how a crude is taken to a consumer, knowingly or unknowingly, we are all there in your household. HPCL today reaches 2.3 crore households daily. Either you come to a retail outlet, or our delivery man is in your house for delivering LPG, or one of the industry partner is there with us, or we are there in the industry delivering lubricating oil, industrial chemicals, and so on and so forth. We ourselves have reached 2.3 crore. There are several companies like us who reach the others. So we are there in your day-to-day life. We import crude from all over the world. There are large ships through which we carry. We process it in our refinery. Again, we have a network of pipelines crisscrossing across India, where the pipelines is the most safest mode of transportation. We take it. We have local storage, terminals, depots, and finally we take it to the retail outlets, which you are all seeing. We deliver products with the quality which has to reach the consumer at the right level. And also the other products and materials what we have been using. At each and every stage, there is an engineering marvel which is hidden behind. Now let us quickly see some of the disciplines which are actually contributing. Chemical engineering obviously is the number one, because as I told, several chemical processes are taking place when I am converting a particular component into another component. Mechanical and materials engineering actually makes these things possible. When I increase the pressure, the material has to have to withstand the pressure, and high pressure is required for complex reactions. Now all this were made possible only if I supply reliable power. The control has to be autonomous. If you see enter a refinery, hardly you will see 50 to 100 people controlling scores and scores of pumps, control valves, etc. You will have more than 20,000 control valves in a refinery operated by just 100 or 200 people. That's made possible by instrumentation and process control, digitalization, automation. All these are also driven by process safety and environmental engineering also. They also play a key role. The solid, liquid, and the gaseous emissions are all closely monitored and controlled. Now, to run the business, finance and economics are required. It cannot be made possible. So, nuances of that plays a large role in making these engineering marvels to excel. Human resources are required to continue the operation, to our capability building, to make the continue with the leadership pipeline. For all this, human resources are required, and finally, management makes all this to continuously prosper. Now, come to what specifics of the marvels I told about high pressure reactors. The thickness of the reactors, what we are having, it's not like few millimeters what we see in our utensils or vessels. They are all 1 feet, 2 feet thick. 1 feet, 2 feet thick walls are required to make our reactors. The distillation columns, our house may be 10 meters, 12 meters. Today, I have high-rise buildings which can go to 100 meters, 150 meters. We have columns also as high as 100 meter, 200 meter. So you should just imagine how they are all engineered, built, and installed. We have high-speed rotating machinery, several megawatt capacity machinery, which delivers the fluid from one place to another. Large heat exchangers and furnaces have come, which are all made through engineering marvels and complex piping system, which I've already seen. Similarly, in the instrumentation, I have talked about the distributed control system. Today, because of the cheap analyzers we are able to make, India is able to make cheap analyzers through semiconductors, through various sensors. We have taken automation to the fullest extent it is being used. So instrumentation marvels you can see with the increased number of wireless controls and so on and so forth. This is very, very important, civil and construction. In the beginning, I told in the world, specifically in India, you have large temples, large palaces, large structures built. That means we had this knowledge several thousand years ago. Now we are continuing with it for making more and more engineering marvels. That is to install our equipment. It has to withstand cyclone. It has to withstand earthquakes and so on and so forth. All these are made possible by the latest advancements that comes in civil and construction, and these are all made possible in a very, very economical way. Now let us specifically quickly see what is HPCL doing. What is HPCL contribution to this technological marvel? HPCL has the India's first lube refinery and largest lube refinery in India. Lubricating oils are used in any rotating equipment, including our cars and bikes. HPCL has recently commissioned India's first residue-based bottom upgradation unit, a resid hydrocracker, which is also world's first LC-Max technology, which increases the conversion to 93%. Sometime back, I introduced the term total distillate, which converts crude to useful product. So 93% of the product gets converted in this unit. HPCL was the first Indian refinery to install an electrolyzer to generate green hydrogen, which is up and running for the last 2 years. We are using crude cavern, which is large structure, geological structure under the rock, naturally forming. We store crude there, which is most efficient and environmental friendly way of storing crude. But it requires an engineering marvel to construct that. Process intensification is used. We are building India's largest integrated petrochemical refining complex in Barmer, Rajasthan, which has highest petrochemical intensity index of 26%. We have the largest hydrogen plants and hydrocrackers. I was talking about the HPCL Rajasthan Refinery Limited. The amount of earthwork what we have done there is more than 150 lakh cubic meter and 6 times the volume of Great Pyramid of Giza. The concrete used is more than 5 times that was used in constructing Burj Khalifa. The structural steel uses more than 40 times that was used in constructing Eiffel Tower. The cables that we have used will run through earth at least two times. So these are all engineering marvels that what we are seeing, just to give you a glimpse of what it is possible and what you all can contribute in future. Now HPCL takes this crude, converts into useful product and take to various consumer points, which are retail outlets, different dealerships, and to new energy. We are also doing CNG, EV charging stations, and so on and so forth. As I told, every day there is more than 2.3 crore customers. Footfall is there doing business with us. These are all made possible with all what we have done through this infrastructure what you have created. To conclude, modern refinery capabilities is a take a molecule, re-architect and convert into a useful product. That is what a modern refinery does. It's a thermodynamic engine. It's a catalytic factory so that you get the required rate. In future, it will become a digital intelligence system. AI-based systems will help us in enhancing this performance further. It's a logistic nerve center. Just imagine when I told 2.3 lakh customers are to be served, how much of logistics we'll have to plan and take it on a continuous basis, round the clock, 24 hours, 365 days throughout the lifetime. We are also responsible. We have removed all the sulfur dioxide. The emissions are being reduced. And now the focus is on reducing carbon dioxide also. So thank you for listening patiently. Hope I would have at least introduced few terms which modern refinery is doing, and also how an engineering marvel enables us to make this possible in the last 2 centuries. You would also have noticed some of the engineering areas where most of you are there, where you can contribute. Tomorrow, what you will be learning more and more, and you can contribute more. I have got several questions. I will straight go to the questions. Several questions I have got. They are all grouped into 5 to 6 different themes. I will respond to them first, and then in the last 5-10 minutes, we will take up if some more questions are there. There are large number of questions asking about HPCL, how HPCL operate, what are the functions we have, how crude is changed, which some I have covered. What I will suggest to all of you, many of you in the coming days will be appearing for different interviews, you will be preparing for higher studies, and so on and so forth. Please visit hindustanpetroleum.com website. You have certain links which gives full details about what HPCL refinery does, what our logistic network consists of, and in a very brief, you will get the entire information. I will suggest each one of you before to continuously you learn, and before attending any interviews, please go through this website Hindustan Petroleum. You will get all the information what you want in that, most of the information. The next set of questions covers or on technology, innovation, and future developments. Upcoming improvements I have covered in my presentation. I can also sum up by telling process intensification, materials development. These two will be two important things when we transit from one form of energy to another form of energy. So please focus on these areas. How are we bringing in innovation and engineering excellence? That is another few questions are there. HPCL has set up one of India's biggest R&D center in Bangalore. We are the youngest R&D center in oil and gas industry, but within last 10 years, our patent portfolio has crossed 700. Our products, technologies, catalysts, what we have rolled out has crossed more than 80. So one of the key things for us is to bring innovation in our day-to-day operation so that we will be self-sufficient in the future. So that is one of our major steps what we have taken. There are good prospects in that area also. May not be only in HPCL, but in the industry and at industry as at the large. There are several questions on energy transition, sustainability, future of oil and gas. See, future of oil and gas, energy transition, these are all very terms what you will be hearing, we will be reading.